Gnss. In a satellite-assisted navigation system, GNSS, GPS, a fix is obtained by measuring the time taken for a minimum number of satellites' transmissions in known positions to reach the aircraft's receiver. The Global Positioning System is a network of at least 24 satellites orbiting the Earth at an altitude of 20,200 kilometers. The system was originally developed by the US government for military navigation, but now anyone with a GPS device, be it a sat-nav, mobile phone or handheld GPS unit, can receive the radio signals that the satellites broadcast. Wherever you are on the planet, at least 4 GPS satellites should be visible at any time. Each one transmits information about its position and the current time at regular intervals. These signals, travelling at the speed of light, are intercepted by your GPS receiver, which calculates how far away each satellite is based on how long it took for the messages to arrive. Once it has information on how far away at least 3 satellites are, your GPS receiver can pinpoint your location using a process called trilateration. The World Geodetic Survey of 1984 describes the Earth as an ellipsoid. The GPS receiver displays provide height above the WGS84 ellipsoid. Clock bias. With 3 position lines, a cocked hat is formed, with a position in the centre known as the most probable position. Components. There's a control segment on the ground, and a space segment and a user segment. The GPS emissions are of 2 signals, the L1 signal and the L2 signal. The L1 signal is on 1.575 GHz and the L2 signal is on 1.227 GHz. L1 carries both coarse acquisition and precision code, and L2 carries only the precision code. Military control. The main difference between the European and American navigation satellite systems is that Galileo, the European one, is under civilian control. The European Space Agency has guaranteed operation at all times, except during exigent emergencies. Users would be notified immediately of satellite problems. On the other hand, the US Navstar GPS system is controlled by the military. The Pentagon can dramatically reduce the accuracy of the service to civilians. Navstar satellites can transmit 2 different levels of service: precise positioning service for military receivers and standard positioning service for civilian receivers. PPS gives horizontal positions accurate to within 58 feet and vertical positions to within 91 feet. SPS gives horizontal positions accurate to within 328 feet and vertical to within 512 feet. Signals are sent from Navstar satellites in codes that must be decoded by a GPS receiver. The codes are precise, P, and coarse acquisition, CA. Originally, P-coded signals were available only for use by military forces, while the CA code was made available for use by civilians. The CA signal allows calculation of a position on the ground to within 328 feet. The P signal offers far more accurate computation of position to within 58 feet. Each GPS satellite broadcasts spread spectrum signals on 2 L-band frequencies, known as channels L1 and L2. Channel L1 carries both P and CA signals at 1575.42 MHz, and channel L2 transmits only P-coded signals at 1227.6 MHz. In the year 2000, responding to pressure from civilian organisations, the US President Bill Clinton ordered the selective availability function to be turned off. CA codes then became far more precise. However, in 2004, George Bush established plans for temporarily disabling GPS satellites during future national crises to prevent terrorists from using the navigational technology. The control segment. This is on the ground and has a master control station which computes corrections, checks for anomalies, creates new predictions, and constructs the new nav message. This is sent to a ground aerial, which provides an uplink nav message from the master control station up to the space segment. The space segment communicates the user signal, which is checked by a monitoring station on the ground, which then sends raw observations to the master control station. Coverage. A satellite needs to be at least 7.5 degrees above the horizon to be picked up. GNSS comparison. GPS, the American system, has 24 satellites, 6 orbital planes with 4 in each plane, at 20,200 kilometers above the Earth, at 55 degrees to the equator. Gnss, the Russian system, has 24 satellites in 3 orbital planes, with 8 in each plane, at 19,140 kilometers above the Earth's surface. Galileo is the European system and is envisaged to have 30 satellites in 3 orbital planes with 10 in each plane, also at a different altitude, 23,222 kilometers above the Earth, at 56 degrees to the equator. India, Japan and China also have their own systems.